Pretty cool stuff, right? I'm Dave Anderson, President of the New York Center for Research, Economic Advancement, Technology, Engineering, and Science, or New York Creates. New York has always been at the forefront of innovation. It's in our DNA. Today, along the same path as the Erie Canal, we've built a thriving semiconductor ecosystem from Albany to Buffalo that will power the next generation of technology. In fact, there's a good chance that the technology of the chip that's inside the device that you're watching right now was developed here 5 to 7 years ago. We're going to give you a tour of the Albany NanoTech Complex, where $15 billion in investment has created America's largest and most advanced semiconductor R&D facility. This site has over 1.6 million square feet, so you're going to get some steps in.
Hi, my name is Christopher Borst. I manage operations and technology here for New York Creates on the Albany NanoTech Complex. We're here in front of our Nanofab East building, the main entrance to the Albany NanoTech Complex. Thousands of visitors per year come through these doors and through this rotunda in order to participate with us in our research activities on site. Here we are in the link between Nanofab East and Nanofab South. It's one of the many links on site that connect the rotundas. Nanofab South is one of the earliest buildings on site. It houses many of New York Creates industry partners, including Tokyo Electron. Their TTCA is the largest technology development center for the company within the United States. We're here in the Albany NanoTech Nanofab South facility, where we use 300mm equipment to bond wafers, dice wafers into chips, and stack those chips together. I'm standing in front of a piece of equipment that performs testing on our chips and wafers to determine whether our experiments were successful or not. If we made the technology smaller, faster, and better, these e-test systems tell that to us. We're here in Nanofab South Annex. This fab performs some of the earliest steps in the production of these test chips. The piece of equipment behind me is used to make some of those metallic connections using the C4 process, which stands for Controlled Chip Collapse Connection. This corridor connects Nanofab South Rotunda to Nanofab North Rotunda. It was built in 2004 to connect those first two buildings on site. Since then, we've built Nanofab Central, and access to that clean room is provided through this hallway. I've just entered Nanofab Central through our main gowning area. We apply these gowns, hoods, and gloves in order to keep particles off of us from interfering with the chips, devices, and wafers that we produce in our prototyping facility. Nanofab Central is one of our most advanced 300mm clean rooms. It's approximately 20,000 square feet of our 150,000 square feet of clean room on site. We use that capability to perform joint development in advanced semiconductor research with our industry partners. When Nanofab Central was built, it provided a connection to Nanofab North, which added approximately 20,000 square feet of clean rooms. This is Nanofab North Clean Room. It's one of our largest clean rooms in the Center for Semiconductor Research. It contains approximately 50 state-of-the-art 300mm pieces of equipment that help us generate today's prototypes for tomorrow's commercial technology. Nanofab North is approximately 25,000 square feet of state-of-the-art 300mm clean room. Here, we have the ability to design, develop, test, and package our wafer solutions. Alternatively, we can send those wafers to our 300mm state-of-the-art test, assembly, and package facility in Rochester, the first open access facility of its kind.
Welcome to Rochester, New York. My name is Chris Streamer, and we're in the 12,000 square foot clean room facility of the Test Assembly and Packaging Facility, where we take 300mm wafers from Albany NanoTech and use techniques such as dicing, fiber attach, wire bonding, and flip chip assembly to make assemblies that can be incorporated into the products that we all use. The advanced packaging at TAP focuses on photonics integration, which is the incorporation of optical devices where electronic devices have typically dominated. This reduces power consumption and increases speed in the devices that we all use.
Similar to Rochester, Albany has many advanced wafer processing capabilities. This corridor connects Nanofab North to Nanofab Extension, our newest cleanroom facility on site. What you see running overhead are prototype wafers moving between fab facilities. They're kept in a clean environment to transport between the clean rooms to continue their processing. This Nanofab X viewing corridor is used to show and explain the technology that we pursue at New York Creates to thousands of visitors per year, whether those are government officials, high school or elementary school students, or potential joint development partners.
Nanofab X is the most advanced 300mm processing cleanroom that we have on the Albany NanoTech Complex. At this facility, New York Creates and partners create nanosheet transistors, more than 1 billion of them per chip, in our most advanced prototypes that accommodate AI technology. Nanofab X is home to the New York State Artificial Intelligence Hardware Center and our Applied Materials Meta Center. Both are state-of-the-art facilities that accomplish joint development work for our partners and for New York Creates. The piece of equipment behind me is an EUV system. We work with joint development partners to create prototype chips that test the algorithms and the processing for today's most advanced AI hardware center initiatives.
I hope you enjoyed your tour and learned something new about the important work we do here at New York Creates. We're constantly pushing forward, constantly innovating, figuring out how to build the next generation of chips, or how to better train the workers of tomorrow. But for now, I've got to get back to work.